Hi everyone, welcome back to the shop. I'm Rob, and in this video we've got our business end. Time to frame it up. So I've got the side plates welded up, and I'm trying to check sort of how flat and square they are, so that when the side beams, like the gantry pillars, get mounted in right here, running up this way, that this, or these two plates where the wheels are gonna run, are actually sort of coplanar with it, and therefore the wheels, or the axis of the wheels, is going to be exactly perpendicular and parallel with the actual frame itself. Now this one actually looks pretty good. Somewhere in the region of maybe 1/1000th of an inch total variation over the surface, which is 1/4 of a millimeter, which is plenty for this. And this guy is about 2 thou below that, give or take, which obviously is 1/2 of a millimeter, or 1/20th of a millimeter, which is more than enough accuracy for this purpose. Now the other one I think is way off due to warping during welding. Yeah, if you look at that, that's what, about 12 thou, give or take, 3 to 15 there. Yeah, does it quite hit 15? Yeah, not where the wheel not where the wheel would be though, so let's call it 10 thou, be charitable. That is 1/4 of a millimeter, which is kind of suspect in my mind. These two are at the same height, but during the milling process it looks like this has rocked under pressure, because it looks like this rear plate is now sort of slightly banana shaped due to just the heat of welding. Obviously this was flat out at 200 amps because it's 1/4 inch material, so even with the cool down periods that I gave it, it really needed more clamping or something. But it looks like this is going to need remilling so that this, no, I guess technically this side and this come down to the level of this, just as you go. As this comes up, this goes clockwise. So this is higher up. And obviously we want it measured from this end, since that's where the mount is going to be. If you actually press right here, it gets fairly reasonable, but that's not really very helpful. Unless, what I could do is actually clamp it here, and then remill this to be flush with all of this, which might be a much more practical way to go. Yeah. Let's try that. Okay, so I've got enough brackets that I'm at a stage I can start assembling now. I have the gantry brackets that connect the x-axis to the uprights, the columns, and I have the wheelbases for the columns that run along the y-axis. Now, the first thing to do now that I can start cutting the extrusion is to figure out how long to make the x-axis, the gantry, in order to get that 12 inches of travel that I want out of it, given the width of the actual carriage itself and also the thickness of the various elements of the pillars that are going to sit on the side, the brackets and the extrusion itself. So I made these brackets to be about 20 millimeters wide, so I'm going to run with that for them. Obviously the extrusion, being 40-20, is 20 millimeters thick, and the carriage is, looks like 97 millimeters wide. So if we add all of that together, we'll want 12 inches, so 12 times 25.4, 304.8, plus 97 plus 80, so that's two brackets, two extrusions on each side for 80 millimeters. We get 481.8, or just over 48 centimeters, which seems like quite a lot for a relatively narrow range of travel, but I guess that's the price I'm paying for the stability of this platform. This has to be quite wide in order to actually be able to deal with the amount of weight that's being slung around here. It's not super light with the motor and the solid head on the end there. And obviously once the air nozzle is on the bottom, then it's going to get even heavier again. So 481.8 divided by 25.4, 18.96 inches. So we're talking about 19 inches, give or take. So let's get that cut and figure out where to move on. From there. So before I can make these two joints with the columns on each side, first I have to figure out how tall I have to cut the columns, which is essentially based on the difference between sort of this distance here, the lowest possible point, to the top of this wheel, more or less. But that still has to be taking into account the actual depth of the laser itself, which would be at least another sort of ½ inch or so below here. And then taking this and then contrasting that with my planned design for the actual sort of base frame with the Y rails and then the connections on each end, plus the height of, or the effective height of these brackets, which in this case is sort of the difference between the top of the Y rails, which is just below this edge here, to somewhere up here where the bottom of the column is going to sit, which looks like it's actually pretty much dead on 40 millimeters here. And then the actual frame should be about 60 millimeters off of a flat surface. And then this height looks like it is, we'll go a little way below that to give us some leeway in focusing. That looks pretty much right at 12, so 120 millimeters. Coming back down, which is actually very interesting. That sounds like these pillars are going to be very short. Okay, so on second thoughts, it has to be to these top wheels, because obviously the pillar has to be the height of this, and then this is the height that the top wheel is riding on. So here to here, about 15 millimeters below here, which is probably approximately my sort of minimal focusing distance, is 160 millimeters. This is set as low as is reasonable for operation whilst maintaining rigidity. And given the 100 millimeter height of the base, including this bracket height, that puts me at only 60 millimeters on the actual height of the pillars, and this length here is only about 47 millimeters, so the pillars are going to be very low, which means the whole thing is actually going to be extremely low and therefore highly rigid, which, again, considering the weight of this thing, is fantastic. Now, this is how I'm planning on having the base frame, with the y-axis rails running horizontally like this, and then the two end connectors running vertical for the separation from the base, or lack of base, as the case may be. This height right here is obviously this height right here. This is just clearance for the wheels to sit almost flush against these plates, instead of having the more traditional spaces and eccentric spaces that typically go into V-slot style build. So this is going to comfortably run against here, like this, and it can actually get very close to the end. So in the calculation of the length of this thing, all I'm going to do is add this width to the travel required, which is 18 inches? Yeah, 18 inches. And that's just going to be my length of those Y rails. It's nice and simple. So the length on each of these is a hair under 110 millimeters, so we'll just use 110 as the distance. More is obviously better when it comes to travel. So we have 110 plus, what is it, 18 times 25.4 plus 110, so we've got 567 millimeters on the Y rails. Yeah, that sounds about right. Let's just roll with that. For assembling this thing, I was originally going to put it all together on the surface plate and use that to perfectly offset these. I was going to mill one end of each of these exactly perpendicular to these side faces, and then use the surface plate to mount them so that everything was exactly square. But since it's going to require calibration and possibly some slight tweaks once the whole frame is together anyway, I don't think that is really sensible, and it would be better just to get it assembled and then sort of bring it into calibration at the end rather than trying to push that from the off, because that probably wouldn't survive the complete assembly process anyway. So I have all the screws collected together that I should need, all the ones trimmed to size that needed to be trimmed to size. Some of them were already in the right length. I have some extra brackets made which will connect the Y rails to the two end rails on the base. There's nothing really particularly special about them, it's just L extrusion, just aluminum angle with holes drilled in it at the right places. And that's it. I'm basically ready to start rough assembling. And then once it's all together, I'll take it over to the plate and start calibrating it in. Alright then. So, that's the frame. More or less. There'll be some adjustments to make. Meanwhile, let's see. If I get my advertised travel distance. No. Not really even close on that one. Where did that stop? Oh, that's interesting. So here's a fun fact that I just discovered. The 17 plus inches of travel that I wanted out of this thing is in actual fact, I've got a little bit of racking problem there, I'll have to look into that, is in actual fact about 15 1/4. Now, there is still under here and under here, between this corner and the weld where they hit together, a good 2 inches. So the actual true travel is still a-okay. The problem is that the actual laser head itself is hitting the end here. The only realistic option is to bring this out 2 inches, which means I would need an entirely different way of connecting these together, because obviously the y-axis rails are not 2 inches longer than they actually are. So it's a bit of a puzzle. I'm gonna have to think about that and see if I can come up with a more elegant solution. Meanwhile, you know, frame is generally together, everything looks good, it works just fine. So overall, still pretty happy with where I'm at. Of course, what I could also technically do is say, oh, it's a 12 by 16 or whatever, and just not worry about maxing out travel distance on a 11 by 17 sheet of paper, which is what I was generally aiming for with this thing. Okay, back to it. It's been about 5 months since the last time I recorded on this project. I think I'm still on track, more or less. I took a look over the current rough edit before I started back up again. So, motor mounting time. Now, I made the motor mounts. I didn't record it because it was kind of pointless. It's exactly the same process as the top plate on the gantry here. Just zipping holes through and then boring out the motor mount. As you can see, I've already got one mounted here to the y-axis. This would be. I decided that these 2 spots right here, since the actual columns aren't going to come all the way forward, this is now touching. There's still at least 13 millimeters, about ½ an inch between here. I can comfortably fit a finger in there. So this is never going to hit here. So I can squeeze the motors in there where it would be kind of difficult back here. There isn't really any space over there. Even though it's technically the back, it's not so logistically feasible, shall we say. I'd rather not put them at the front, but I don't think it really matters all that much in the end. So, I'm going to get the second y-axis motor mounted up, and then I've got to figure out where I'm putting the x-axis motor. I think, I was looking at this a couple days ago and now I can't remember, but I think it's going to end up something like this. Possibly. Or I guess technically I could probably just about squeeze it in like that. That would be kind of tricky to put the actual belt drive in though. Ooh, there we go. Back of the column right there. Even sticking out, it doesn't hit the stepper motor on the back here. I'm still not touching that Z-axis stepper with the mount, and then there's plenty of space back here that I could squeeze in some kind of belt mounting system and pulleys at the other end. It would all be good. So yeah, I'm gonna get on with that. Okay, so I've got the motor mounts installed. The 2 Ys right here, and the X is stashed back behind here. I put it on this side because that's the direction it ended up on the mounting plate. The why wires are actually inside the V slot. It just so happens that a T-nut will slot down inside the extrusion whilst still leaving room for the wires. So what I may do at some point is use that to actually mount a little strip of aluminum on there, just as a sort of neater cover, go with the black and silver theme going on here. Other plates I'm going to need to make now are going to be the 3 idler pulley plates. So I've got the idler pulleys, 2 different kinds. One is a like original open builds one, and then a couple new style ones, I guess. They're going to have to go sort of opposite the motors on each side of the axis, and then this one is going to have to go sort of up here in line with the existing pulleys. So I need some way of mounting those. They've got bearings inside, so there's no need to get too fancy with it. Just something that I can bolt it onto and maybe have a little bit of adjustability might help. I don't know. Other plates. Oh, gonna have to figure out how I'm gonna mount these optical limit switches. I've got 6 of those. I may not end up using them all. I'm not sure how I'm gonna do it yet. If I go with moving switches, then technically I could probably just about get away with 3 per axis and just have some kind of plate that interferes through the little gap on each end of each axis. I don't know if that's going to be practical in all situations, so I got the 6 anyway, and we'll see how that goes, but I'll need to make those plates. Okay, so I'm going to have to interrupt myself there. I think it's going to be better if I just bring you up to speed rather than pontificate about what may have been. So as you can see, I'm in the future now, and this thing is done. So I'm going to show you what I did to finish those things off that I was talking about, and why. So, first things first, were the pulleys, so I could get the belts on here. Those were super straightforward, just simple plates drilled, screwed in, done. Belts are mounted with just little pieces of angle aluminum. Same on here. Only difference is this is a little further away because the motor is physically mounted further away, but otherwise exactly the same. Drag chains. I didn't bother ending up fabricating custom mounts for the other piece of this guy. I just went ahead and bought a whole second drag chain because I was super over it by the time I actually got to doing it. It actually worked out for the best because this ended up being a fair bit bigger than I thought it was going to be, and that's probably actually going to be required for all the cables that are going to be running through here, plus probably the airline. At least that's the theory. On this guy, it's probably going to have to be zip tied. I don't think the actual like threaded fittings will fit through that. Those were pretty easily mounted. Simple plates for these. This one's a little welded up angle plate that mounts both to and sits on top of this upright here, so it's super stable. Not that it particularly needs to be, but I figure once it has the weight of the wires going through it, it might want to move around a bit more. I don't know, we'll see. And this one, obviously, I made this whole entire channel from a piece of aluminum angle that I just cut in half and then tacked together, and then welded some quick brackets too that screw right into the end pieces here, each side of there. It's again super straightforward, but keeps all of this weight in line and nice and clean and running, so worked out well. yeah, that's that. And final piece was the limit switches. I actually changed from optical to mechanical limit switches, like micro switches. Basically because the optical switches were overkill. Like, there's no reason to use those on a machine this simple and, you know, inexpensive. These should be plenty reliable. They got pretty good reviews. The only thing with them is they say MakerBot design, so I don't know if these are the same ones as are on the actual MakerBot. I'm not sure. I just found a pack of 6 for like $10. But the board itself is drilled asymmetrically. So when you're actually mounting it, some of them mount really nicely, like this one, where the 2 holes just go right into the V-slot, problem solved. And then the same on this one right here, the 2 holes are drilled right and tapped right under there, 2 M3 screws, boom, done. But on the other side, you've got to custom fabricate little mounts so that it holds it in sort of the right location and orientation, because you're a little bit limited on stopping it from rocking based on where the actual V-slot is. So on this one I actually have a little video clip real quick of finishing up and installing this bracket, just so you get the idea. That's here. And then looking at the Z-axis, some of you might have seen this on Instagram already, but this, as you can see here, I took this whole thing apart and machined an angle into here, which basically cam actuates this little rounded bit of the switch right here. Because this isn't a roller cam, and this little piece of sheet steel at the end here seems like it would want to get caught on stuff, this seemed like the most sort of bulletproof, reliable way of actuating it at a specific height. And that's mounted on this adjustable height. You can see the slot here. So this whole thing can ride up and down if to sort of calibrate the exact height I want to stop it at. On this custom plate right here. That would be the Z plus switch, and then the Z minus switch, because it's going into, like, I don't know where. It's going to be per sort of run, depending on exactly where the workpiece or what it's standing on or whatever would be. I don't know exactly where it's going to bottom out. So for Z minus, I'm just going to use Goebbels built-in soft limits and not have a physical switch. I googled it and that seemed to be what everyone does who has an actual full moving Z sort of base rather than a standard linear slide up here. So I don't think it'll be a problem. It seems to work for everyone else, so I'm not too worried about it. Okay, that's basically it done. Frame put together. Wiring mostly still needs to be done, but I'm not super concerned about that. It's certainly been a learning experience. The main lesson of which is probably don't build a machine without fully modeling it in CAD first. I'm going to go with that one as the primary lesson. But a lot of the smaller stuff, the actual motion stuff and the limit switches and all that, will be taken forward to the mill conversion. I think some of the difficulties I had there should translate to future machines, plural. I do have plans. but I have enough on my plate for now. So I hope that was useful. If you're planning on designing and building your own machine from scratch, or if you're planning on modifying an existing open builds or inventables or something machine, I was trying to go through a lot of the sort of considerations involved rather than just saying this is how to screw a machine frame together, which isn't really very useful at all. And hopefully there was a fair amount of that in there. Now, next video is gonna be, it should be the last video as originally planned. It's gonna be all electronics, flashing Gerbil, doing all of the settings in Gerbil, because there are quite a few to go through. I've seen a number of people have difficulties actually parsing through the wiki on GitHub to actually get up and running with it, so I want to try and cover that in some detail. Maybe some of the basic electronics and wiring. That's mostly common sense kind of stuff, so probably not too much of that. And then vectors, G-code, and first cuts. Should be good. So if you like this, and you like the sound of that, then subscribe for more of the same. And in either case, thanks for watching.